Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast. Welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Tamaki Makaurau, Auckland in New Zealand, and I am welcoming back this week Mary James. Mary, how are you?
I'm good.
And also Jay Fox. Good to see you again.
Good to see you as well.
And Zach is back from, where have you been, Zach?
Yeah, I was just down the road in Portland, Oregon at Passive House Northwest's Spring Conference 2025 that was focused on resilience and adaptability. I had the privilege of emceeing the conference on Friday and then attending a bunch of project tours on Saturday, which was really fun, including the retirement center that my great-grandparents lived in for like 25 years in the 80s and 90s and in a little bit into the 2000s. They both were 103 when they passed away, 1 year apart, and had lived independently for decades at this retirement facility, Rose Villa in Milwaukee, Oregon, which is just south of Portland. And the retirement center, the ownership of the retirement center is really leaned all in on resilience and climate mitigation. So they are doing net zero construction for all of the new buildings that they're creating in the community. And so we toured a couple of them, a couple of the new parts of the campus designed by Green Hammer, and designed and built by Green Hammer. So it was really fun to see that, and a fun kind of connection to my past life and the fond memories of two very cool people.
Yeah, you got some good genes there by the sound of it.
And at least on that side.
Great that you got to MC that event, and obviously resilience is continuing to be a big topic and probably will be for some time. Was there much talk about people getting into the actual rebuild stage of things, or is it more just talking about design phase?
Yeah, good question. Like rebuild after fires and that sort of thing. There wasn't a lot of focus on rebuild from fire. There was a lot of focus on protecting buildings from wildfire smoke, from heat events. A lot of discussion about the impact that the heat dome in 2021 had on all of us here in the Northwest in terms of how we think about buildings, and how to protect our buildings from these crazy events. It was 116 degrees Fahrenheit in Portland during that heat dome, which is, just so far off the charts. It's crazy. And so lots of discussion about, okay, so given that is now, we know that can happen, how do we design our buildings with that information moving forward? And there was an epidemiologist there talking about the real impacts on human health that these things like the heat dome have, and actually enumerating how many excess deaths happened in Washington State during that period. So there were a couple of hundred people who were killed in Washington State alone. And of course, the heat dome impacted Oregon and British Columbia. So I think those numbers are quite a bit larger. And also some, thinking about how to move forward and build a future that is resilient and that we can thrive in. So it was good. And Josh Salinger and Greta Cheltfight, who is the board president of Passive House Northwest, and their team did a really excellent job in pulling the conference together. I think people really enjoyed it, and Passive House Northwest does a great job. So it was really fun to see old friends and be part of it all.
Nice. Sounds like some really great content that'd be good to dive into more detail with some upcoming episodes, both at Retirement Village retirement sector is really pertinent to energy savings and resilience. And also that the impacts on health, I think, is a really interesting topic as well. Kind of related, we are talking facilities today. Really interesting conversation that Jay and Mary had with Jessica Grove Smith, who we haven't heard from for a little while. Really nice to hear from Jessica again from PHI. So we'll get into that, but before we do, we've got a few people to thank, Zach.
Indeed. So we'd like to thank our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwool North America, and Zola Windows. Thanks to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Facro, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Technologies, and Source 2050. And also a big shout out to European Architectural Supply for being our sponsor of the week this week and making all of our programming possible.
All right. Well, let's get straight into this week's interview. This is, as I mentioned, Jessica Grove Smith, talking about a recreation facility and a pool, which are in very hard to design for traditionally, because they often have lots of condensation because you've got a big swimming pool in there, which she goes into. And I think Jay and Mary do a pretty good job introducing this and around the context of this. So let's dive in, and we'll catch up after this interview.
Welcome to the Passive House podcast. Today, Jay and I are speaking with Jessica Grove Smith, Senior Scientist and Joint Managing Director of PHI. Welcome, Jessica.
Hi, Mary and Jay. Nice. Thanks for having me.
And today we want to talk about leisure centers and also known as recreation centers, and in particular buildings that have high humidity issues, such as leisure centers with pools. And I know that PHI has done a lot of research with different building typologies. So could you just walk us through a little bit of PHI's history with this type of building?
Yeah, it's a really interesting story, and it's gone on for now several years. I looked it up when I was preparing for the podcast. And when we started our research work for this typology, so projects, leisure centers with indoor pools, so the focus being on kind of the pool aspect of it, it started around 2008. Coincidentally, complete coincidence, that was around the time I started to get into Passive House when I started at PHI. So I joined the team who just started working out on the topic here at the Institute, joined my colleagues. And it started out because one municipality here in Germany, Lünen, they had previous Passive House experiences from schools and other buildings, and they were looking at building a new public swimming pool for their community. And they knew that's an expensive building to run. It's very energy intensive, and they wanted to look at what can they do to bring down that energy demand. And they approached us to see whether we can somehow collaborate on it. It was a completely new topic for us, so we knew that we couldn't not just use the normal processes. We had to do some research first. And we were able to get some funding in collaboration with that municipality and their pool operators to get some funding from the German Federal Environmental Foundation. They do kind of these funding programs, and they funded a baseline study first of all. So we, together with the municipality, did a baseline study to understand the typology, understand kind of where is the energy going in those buildings, what is so energy intensive about them, and then work through it step by step in terms of how can we bring down that energy demand. That's how it all started, 2008. And the fantastic thing about it was because we had a real life project to work with. That baseline study where we started to understand, okay, the building fabric is a really important element in it. We're dealing with very high temperatures inside, around 30 degrees in the pool hall. We're dealing with high humidities. The building fabric is one thing, but there's so much more to it that you can do by optimizing the ventilation systems, by bringing down the evaporation, dealing well with those humidity loads. There's really a lot of potential. So we did that baseline study, and then we were able to very integrated design process with that municipality and their design team, implement those initial research ideas in a real life project. So taking that theoretical research work and applying it to the first then pilot passive house project. So that's how it all started out. That project opens its doors in 2011 and was really an ideal scenario of how it should go, being able to do the research and then apply it to a first pilot project.
And so when a project team who's trying to build a relatively novel building typology, in this case, like St. Sidwell's, who built a recreation center in Exeter, when they come to PHI and say that they want to certify, what kind of consulting and supportive services can they kind of expect to receive?
So it depends a little bit on how new and how complex the typology is. So in this case, the first ones were in Germany, and that was completely new. So we started out with a theoretical baseline study and then worked with the team throughout the entire design process to start implementing that. We then learn from project to project. Every project we gain new experiences. There was a second pilot project in Germany happening around the same time. When they heard about our baseline study, they became interested and said, hang on, we'd also like to do this with you. So we worked with them. And it's a very close-knit collaboration. The design team is obviously responsible, but we'll do the PHPP modeling and we'll support on kind of the technical optimization, looking at the extra step that Passive House can provide for them.
How did it come about that St. Sidwell's, the team that was developing St. Sidwell's, approached you, and what happened then?
So from those two pilot projects in Germany that opened their doors in 2011, we were able to monitor those two projects very closely, both of them for 2 years. So we got feedback, 2 years of in use, where we work closely with the operators to really check that what we'd anticipated through our initial research and those first pilot projects, to see whether that was working in practice. And that was very positive feedback. We had the monitoring data, we had the proof of concept that the initial research worked out. And based on that, all of those research reports are published. I'm happy to share the link with you. The detailed reports are in German, but we have summaries on most of them also in English. But all of that publication, all of that is available, is published. And then other teams started picking up interest, seeing what we'd done, seeing that it worked in practice. And then the first big project that came up outside of Germany to said, this looks really interesting, we'd like to apply this also to our municipality, to our project, was Exeter City Council with their St. Sidwell's Point. So that was the first project outside of Germany. It was the first project in the UK. It was also larger than the two projects in Germany in the sense that it had more leisure facilities. This one also included a gym. It included more sports facilities. So it was more of a, again, a different facilities mix to the first pool projects in Germany. And when the team approached us from Exeter, very committed team from the city, who want to really showcase and lead the way and say, we as municipality have a possibility, we have a responsibility to build energy efficiently. It was it was great to work with them because they were so committed and so behind this vision and this goal of having an energy efficient leisure center. So when we started working with them, at the same time, we were still working or summarizing, I'll say, the research work from the two pilot projects in Germany, summarizing and putting them all together into a pool guide. So from those initial years of experiences from Germany, after having done 2 years of very intensive monitoring on those pilot projects in Germany, we summarized all of that information into a comprehensive pool guide. The idea being that by having a guide as a free download PDF document that people can download, it gives them a starting point to say, what is Passive House for Pools all about? How do I start it as a design team? What does it mean? What are my targets? What are my goals? What are the energy efficiency measures? And that pool guide has been really instrumental and helpful to get teams started, also to raise awareness, to get interest, and get kind of more projects on this track. And St. Sidwell's happened round about the same time as we were publishing that pool guide. So there were a lot of synergies there, no? Us supporting that team in Exeter and summarizing those findings into general guidance.
So I've heard you before say something similar to, well, when you're approaching a complex project, break it down into the pieces. It's a little bit more manageable. So when dealing with these leisure centers and pools, can you just tell us what are some of the biggest challenges or the biggest pieces that project team has to deal with?
Yeah, there's a lot of technical details to go through for this typology. But what I find fascinating and what's really always an eye-opener when I speak to the teams and get started on these projects is that the building fabric, which we're so familiar with, and it's always fabric first on Passive House because that one was one big driver to bring down the energy demand. The interesting thing is that building fabric opens a whole door for more energy savings in this typology. You have to imagine we're dealing with spaces that are very warm, that are very humid. And a big risk in conventional buildings in pool halls is they have that humidity and they have the risk of condensation on those cold facades. And because in our passive houses, our facades are such high quality, they're warm, we have these warm surfaces, we don't have that risk of condensation anymore in the pool halls on those walls. And that opens a whole nother range of opportunities. We now have much more flexibility in terms of the ventilation for the pool halls can be operated much more efficiently. So we don't need to blow warm and dry air onto the facades anymore to keep them safe because they're warm and dry anyway. So we can reduce the amount of recirculation or not have recirculation at all, which is a big, big electricity saver. And we can increase the levels of humidity in the space. No? And by increasing the humidity levels, we reduce the evaporation. And evaporation is one of the biggest energy losses in this typology. You know, all that water that evaporates from the water surfaces pulls heat out of the water, but also means that we have to dehumidify the space more. So the less evaporation we have, the better. And it's really interesting that what do you call it? Kind of the consequence or the extra effect of having the better building fabric means that we can reduce the evaporation and have kind of that knock-on effect of even more efficiency. So it's a really nice example of how Passive House is this whole building approach. It's not just looking at one individual component and optimizing that. It's not about just stopping at the building envelope and everything else stays the same. It's really looking what's happening within the building, how does it all interact with one another, and how can we overall improve the system to bring down the energy demand as low as we can.
That's really cool. I didn't think about that, the evaporation, but I guess to unfortunately harp on one part of the building and the building enclosure, specifically with the airtightness strategy, like how does that shift at all when you're designing for an indoor pool, if it does, and specifically within a really humid environment like the UK, did that have any effect on how you designed the enclosure?
To be honest, for the air tightness, it doesn't shift that much. I mean, passive houses generally, we're used to having very good and very high air tightness, but it is a little stricter on these buildings. As I said, no, we have the very humid conditions inside the space, and in order to really protect the fabric, in order to reduce those losses, we have slightly higher targets for the air tightness on this typology, no? Mainly for quality assurance and for protecting the building fabric. But the approach and the systems and the quality assurance that we know from passive houses for very good air tightness essentially are very, very similar. It's just, no, you have to make sure you really have that quality assurance on site for a slightly more stringent target.
So could you be a little more specific? Because I mean, for most people, 0.6 ACH50 is quite a stringent target. So
True.
you want it to be more stringent?
Yeah, we do. We do. So the normal passive house metric, as you said, is the 0.6 air changes for the leisure centers or the pool halls. We've gone to the metric towards the referencing the surface area. So it's a Q50 of 0.4 that we're asking for leisure centers. Yeah. And it's because of that humid air, warm and humid air within the space and wanting to really protect that building fabric. Yeah.
And what about glazing? Does
Mhm.
does your approach to how much glazing the building has? I mean, on the one hand, I can imagine people want a lot of glazing in an area with a pool so that
Mhm.
they get natural light when they're swimming. But on the other hand, I don't know how that would affect the control of the temperature inside the building.
As with every passive house, you need the energy modeling to be helping you along with this, no? To find the good balance and the right balance of glazing, the glazing in terms of the solar gains you're getting, but also the heat losses through those windows. It's interesting. It's quite different in pool halls because these pool halls in the climates that we worked at so far, which are cool, temperate, moderate climates, the pool hall actually has a heating demand throughout the entire year. Even in summer, the temperatures are still colder than we'd like to have them in the pool hall. So we have heating demand throughout the entire year, which means we can also benefit from solar gains pretty much the entire year. And actually, we've seen in several of the examples that it's beneficial. It's quite good to have a good amount of solar glazing if it's facing south, obviously, if you can benefit from solar gains. You have to be a bit careful. One different thing about this typology is that you have to take into account glare, the safety factor of having the solar radiation hit the water, but that's a design task that every typology, every project with a pool has to deal with. But from a glazing perspective and solar gain perspective, actually, the kind of big glazing and solar aperture can be beneficial for the pool halls. I'm talking only about the pool halls here. And actually, that's something that's quite interesting. And one thing that I can advise any team working on this typology to look out from the very, very start of the project is to understand your building well in terms of what are your set points, what are your expectations for the different zones within the building. You're going to have the pool hall, which is the most warm and the most humid. You're going to have the changing facilities, which you still want quite warm because people are walking around wet and they're having their showers. So you still want them at a comfortable 26, 28 degrees. I'm sorry for doing everything in Celsius here. Maybe we can add the Fahrenheit in the in the notes later. You can translate.
But I
And then,
grew up close to Canada, so I understand.
okay,
Understand it pretty well.
good, good. And then obviously, depending on what other facilities you have within the building, there's always some circulation. There's your entrance space, which you typically have at your normal 20 degrees. And then in some of the buildings, if they're larger leisure or recreational facilities, you might have a gym or you might have a multi-use room or you might have a studio, which might even be cooled, keeping it at colder temperatures. So you really have to understand what rooms you're dealing with, and it makes sense. It's going to make the entire project easier and cheaper and more robust and more reliable if you think that zoning through from the outset and say, okay, I'm going to put my warmest spaces towards the south, and then ideally have a buffer zone in the middle. So that could be your changing in, for example, and then have your offices, have your entrance, have your cooler spaces towards the north. It's going to improve your comfort, and it makes the design so much easier. Because otherwise you're going to have to deal with having thermal separation between those spaces to make sure you're not losing heat or you're not overheating the spaces that we're trying to keep cool. So that zoning is something that I can't overemphasize, to look at that from the very, very outset.
And I did want to ask about passive cooling strategies, but I'm realizing that might be kind of irrelevant after what you just said.
Well, yes and no, to be honest. It's not that relevant for the pool halls
Yeah.
because they do need heating all year round. But it does become relevant for the adjacent spaces. So again, this comes back to the zoning. You have to be very careful to not place areas that you want cool. You want to keep cool directly next to the pool, or you're going to have a certain minimum amount of thermal separation between the two. All of the projects, so since Sidwell's in Exeter, and all of the projects that are happening now as follow-up projects, they are using natural ventilation, night purging in those adjacent zones just to make sure those stay nice and cool and comfortable during summer.
And
So there are certainly still natural ventilation and summer cooling strategies for those other spaces within the building.
this is maybe a ridiculous question, but it just occurred to me. You have your different exercise rooms, your spin room and your dance room and your sure like a weight room. Which one tends to have the most like heating due to physical exertion? Like, did you model that, or is that
We did. You
Okay.
have to. We
Yeah.
have to, right? We end up in these projects, we end up with multi-zone modeling. So you can't throw all of this into one PHPP because your boundary conditions are so different, your set points are so different. So you end up with a multi-zone PHPP, and you model kind of every part of the building that has a similar use and similar set points as one PHPP. And
Mhm.
obviously the pool hall will be one, and the ones that have the highest internal heat gain from the equipment and from the people are the gyms. So the gyms with all of that fitness equipment. You can influence that depending on what fitness equipment you choose.
Mhm.
So there is still a possibility from the operators, from the client, to influence that, but those are typically the spaces where you have, from the people and from the sports equipment, where you have the highest internal gain. And those are then also the spaces where you typically have active cooling, which is fine, not a problem. Actually quite interesting because, as I said earlier, we've got heating demand all year round. So there's a really interesting possibility, and we've asked that of all of the projects that are now underway, that they from the spaces where they use active cooling for the gym, for example, they recover that waste heat from cooling and use that heat to heat other parts of the building, whether it's space heat or whether it's using that heat to heat the pool water. But because there's always a heating demand, you can kind of heat and cool simultaneously and make sure you're reusing the waste heat from that cooling for other parts of the building.
That's really cool.
Mhm.
Yeah, I mean, it must be a certain amount of, I mean, it sounds like you couldn't use a scheduled amount of heating because you don't know how many people are going to show up for the gym that day. So I'm assuming there must be some sort of variable demand that you're using to capture that waste heat, whether it's the waste heat is coming from the pool or whether the waste heat is coming from the more active gym rooms.
Yes, so the waste heat is always going to come from the gym, right? You've got your
Oh, right, because
that's the only spaces where you actually have active cooling,
uh-huh.
where you can use the waste heat from that cooling. And yes, it depends on how actively it's being used. But I think nowadays systems and controls are clever enough. No, if there's no waste heat from cooling, if there is no cooling at the time, then the heat has to come from outside. So there's the heat pump configurations that can go either way. Either if there is cooling, they'll use that heat. If there is no cooling, then they'll use the outside air as heat source for their heating. Yep.
So are there other
Mhm.
ways that HVAC systems need to be particularly configured to work in leisure centers with pools?
It's a good question, and I think we could dive into technical details on all of the different nuances and systems. I was trying to think of kind of some specifics that are unique or worth mentioning. What we found is one of the topics that we spend a lot of time with as part of the consultancy, as part of the design process, is to look carefully at the ventilation, for example. So it's a balance of trying to keep it simple, but yet having a system that is demand-based control. Because in these projects, the ventilation system often get very generously sized in order to be able to deal with high occupancy, which can happen temporarily, but most of the time you'll just have an average load or you'll have less people, and to deal with high humidities that can happen if you have a lot of people showering at once or if you have a lot of people jumping into the pool at once. You have to be able to deal with those peaks. So traditionally, the ventilation systems are sized very generously, and maybe they turn down a little bit, but that's not enough for our passive house expectations. If you look at the energy balance, then both the heat losses from the ventilation system can be quite dominant, as well as the electricity demand, not to run those fans all of the time. So talking through and really optimizing the ventilation concept for these typologies for this building is always something that we work through with the design teams, trying to use transfer air where possible, so supplying to changing rooms and then extracting from the showers, for example, rather than supply and extract to both of those separately, and having demand-based control. So the system can ramp up and down depending on how many people are actually using that space at the time. Technology's there. It sounds fairly straightforward, but in practice, we found it's worth spending time and really looking at that with the design team, understanding how the system is set up and understanding those controls and how the project is intended to operate. It's really worth understanding that and discussing it as a team to make sure that the project will then run reliably.
And commissioning afterwards.
Commissioning, yes. Commissioning, thank you. Really, really important one. And I find that often projects at the end are a little rushed. They're trying to get over the finish line. They just want to get that commissioning out of the way. So again, I'd say that's not when you want to rush things. Commissioning is absolutely essential and important, especially, the more complex the projects get. It's obviously in part of Passive House, part of the quality assurance and the certification that we have expectations. We need to see the commissioning evidence. We review that carefully to make sure the project's set up. It's a big part of it, and that can add a little bit of time at the end to make sure for these complex projects it's running well. I'd say it's really important that the design team and the people carrying out the commissioning speak, with the Passive House designer and the certifier early enough to understand what the expectations are for the commissioning. So you can do it all and submit, there's certain information that needs to be there. Otherwise, it can be a bit of a tedious back and forth. So it's important to get your commissioning prepared well. To have your project run. And also important, commissioning, no compromises there, but it's also valuable for the operator, for the client, for the team to think in advance of how they're going to give some sort of feedback loop to the operators, so that once the project is in use, once they're on their own, once they're working with the project, they get feedback in terms of where are we at? Are we close to where we're expecting to be with our energy performance, or are we not? It's really, really valuable to think about that and see how can the BMS give feedback to the operators, because typically the operators aren't as involved during that design process, as everybody else. So giving them some tools and aids to be able to track the performance is super valuable. We have some templates, we have some guidelines that we published as part of our pool guide, but we see that every team is approaching that slightly differently. I think there's still a bit of potential here to streamline that and give teams more guidance. It's something I've seen as quite important. These first projects, we were heavily involved. Obviously, the first 2 pilot projects in Germany, we did very, very intensive monitoring. Since Sidwell's, we're also involved. Our project has been live now for more than 2 years. We're working with the operators. We're keeping track of the energy performance. We're in contact with them constantly, checking where things are at. Where do they still need to be improved? But the next iteration, the next kind of phase of project, they're not going to have that involvement anymore, and it's not a sustainable solution to always have somebody involved who's checking constantly. So you need to make sure you have systems in place that the operators can do that themselves.
I guess just playing off of that in terms of I don't know, ways to monitor. Are there additional things that you're monitoring within a building with an indoor pool that you would in a building without a pool? The future people who are thinking of designing a pool, are there additional just metrics that you're monitoring for a pool?
Yeah, I think several. The most obvious one that comes to mind first is the whole water treatment equipment, right? So the whole thing of the first of all, the pumps that you need to circulate that water 24/7, and all of the additional equipment that you need to keep the water at a hygienic, clean level. All of that is a big electricity consumer for this typology. We have energy expectations. We actually have targets for how much those pumps, so those circulation pumps that run 24/7, that's part of our process where we interact with the design team and say you have to optimize these systems so that their energy consumption is limited, and that doesn't necessarily get tracked or linked to the BMS, but that's definitely something that's worth feeding back and keeping an eye on, because that is one of the biggest electricity consumers in these buildings.
And just sorry, I want to keep going down. Is there, are there any energy efficient models for some of these really like niche components that you need to keep up a pool, or if those not really been developed yet, just because again it's such a niche thing? And
what do you mean by models? Modeling tools, or
you mean the pump?
The pumps themselves. I assume that
they're nothing special. I mean, to be honest, they're just normal water pump. They're circulation pumps. It's not necessarily fancy technology. The bit that you have to be very careful about here is that you choose the right equipment.
Mhm.
So again, it's a matter of understanding your project, understanding it well, and choosing the right pump. So traditionally, maybe if you're not that focused on energy efficiency, you would design your project, have a certain amount of pipe runs. You'd calculate your head loss from that pump system, but you're always going to choose a pump that's on the safe side and can definitely deal with the circulation rate and definitely lead with that pressure head that you might have in a worst case scenario, which means that that pump in the actual operating conditions, which could be a slightly slower, lower pressure head, might run really, really inefficiently. So one of the things that we engage with and that we point out and that we ask for is to choose a pump to really understand your operating conditions, calculate those pressure losses detailed, so not just a rough calculation, but really look at what's your pipe size, what are the different fittings, what are the pressure losses from those, understand what your pressure loss is going to be, and then choose a pump that performs efficiency at that operating point. So the pump itself is not magic. That's fairly standard equipment, but choosing the right one for your project or your operating conditions is something where we have found that the design teams have to work a little differently to what they might do on other projects. Be more aware and be more conscious.
You mentioned following St. Sidwell's. I don't know whether you're doing it for 2 years as you did with the other schools in the pilot schools in Germany. As you've been looking at the data, have there been surprises or changes that you've noticed that you've communicated to the owners to deal with?
Yeah, so it's a slightly different setup to the first Peru project where we kind of did a very, very detailed analysis. No, we had very granular data. We took that away for 2 years pretty much and did very, very detailed analysis. In this case, on St. Sidwell's, we are involved, but on a higher level. It's more looking at the main meters. There is granular metering, so we do know where the heat is going to different parts of the building. And then we have regular calls with the operator to check where things are at, which things are running and which things are not quite yet where we'd like them to see. We've published the first year of data. So after 1 year is up, we compared what is the energy consumption of that 1 year. That's published in an article on Pacipedia, which I'm sure we can link somehow, so that listeners and readers can take a closer look. And from that 1 year, it's actually 2 years now, so we have 2 years of data. And it's really encouraging to see that data confirms that especially the heating consumption is really, really low. It's really great to see that approach of fabric first, of really, really bringing down that heating demand, has worked extremely well. For Exeter, we have a comparison of St. Sidwell Point with another leisure centre of a similar size, same climate, but an old building, and you can see a massive difference. It's over 60% energy savings between that existing building and St. Sidwell's Point. Where we're still a little bit off and where we're still working with the client and working with the operators to get more improvement is on the electricity consumption. So the whole point that we were talking about earlier with commissioning and controls, it is something that's tricky to work out. It takes time. So that's something we're still working through. But overall, I mean, the project is fantastic where it is at. And we're going to keep working with the client to understand where the consumption might be higher than expected, to bring that down further and take learnings from this for the next projects, right? Especially that electricity shows us that we have to be careful during the design. We have to work with the design team to understand where the consumption could be coming from. So as part of our energy modeling, again, whole building approach, we want to know everything that's in that building. We want to know every little piece of equipment because it all adds up in terms of the electricity consumption.
I'm sure there's a bunch of different leisure centers that are in the process of being designed or modeled at this point. Are there any in North America that we can look forward to, or?
Yeah, so the most projects are happening in UK at the moment. It's again super interesting and fascinating how since it's created a bit of a ripple effect. It was the Exeter City Council super motivated about it, spoke about it a lot, and we have a number of follow-up projects, at least 5 across the UK, who are some of them final steps of certification, some just starting out, so that wide range. And we're now seeing it pick up also in other countries. So France is picking up. We have a few in Spain, which is hotels with pools, so slightly different typology, but no, that's what's picking up interest in Spain. It's that kind of hotel industry with pools. And yes, we do have first inquiries from North America, and Vancouver seems to be leading the way. We've done some initial support and consulting, and we hope to be further involved and maybe see the first Passive House Leisure Centre in Vancouver.
So as a former New Yorker, I still feel a little competition with Vancouver. They tend to always beat us a little bit, which is upsetting. But I guess that's a good thing that's finally coming to North America. But I'm curious now, just about the kind of the public response to specifically St. Sidwell, because St. Sidwell's point, because we keep kind of focusing on that. But like, I guess the two pools in Germany and St. Sidwell's point. How have people enjoyed, using an indoor passive house pool? Like, have they noticed a difference that you're aware of, or are they just like, this is just a pool and I'm going and it's comfortable?
I can tell you that St. Sidwell's is super popular. So the number of guests, the number of visitors that they receive per year are way in excess of what we'd anticipated during the design. It's a very, very popular center. I can't say exactly what that comes down to, whether it's only passive house or whether it's just a good facility in a good location. I think it's probably a combination of all. And the projects in Germany, people are happy with it. Yes, they're using it. They're good, popular projects.
It makes sense that if you go to a pool center and you're more comfortable in the locker rooms, I mean, it's so unpleasant to go swimming somewhere where, it's like freezing until you get to the pool, which happens on a regular basis. So I can understand why it would be a popular facility.
Yeah.
Well, I really appreciate the insight that you've given us into designing leisure centers. It's, a complicated building type, and I'm sure the pool reference guide will be really helpful for anybody who's contemplating that. And it's great to hear that the hotel industry is starting to get interest, because there are so many hotels with pools, and it's easy to imagine that they can be a big energy sink for the businesses that operate them.
Yeah, definitely. Definitely. Yeah, no, it's a fascinating typology. There's a lot more technical detail we could dive into, and I recommend everybody to start out with the pool guide. That gives a good kind of overall picture of what we're aiming to do. And then speak to the people who've involved in design, speak to the clients, who've committed to doing this, why they're doing it, and how they're doing it. The team from St. Sidwell's, for example, they visited the two projects in Germany before they fully went on board and committed to it. Experiencing it is always a fantastic way to get started on that journey, and fun to work with. I really enjoy it. It's a fantastic mix and always good teams, and there's always something new that you work in and optimize. It's been a journey, as I said. I started, it was one of my first research topics when I started at PHI, and I've been working on it until today, and it's really, really been great to be on that journey and keep developing and evolving and learning working with different teams, and it's a great typology, great project to be working on. Also because most of these, or a lot of these projects, are public buildings. They're offered by the municipality as a health facility, as a leisure facility, as a sports facility for the community. And I think that's it's great to be able to support municipalities to continue to offer this service, and doing that with a reduced carbon impact, and also supporting them to reduce operational costs. I think these types of building can be a huge cost burden on municipalities, on operators, and bringing down those energy costs. It's great to be working with clients to that end.
And it'll be interesting. I was just thinking it'll be interesting to see the operating cost effect in a different climate, like somewhere in Spain, just to be able to have more examples in different climates is wow.
Definitely.
Again, going a little veering off, but in a region like Spain, where I'm assuming it's a lot warmer than the UK, does that kind of change? Like, now, do you have a lot of active cooling that you need to provide within the pool room, or does it still remain mostly heating?
So the climates that we've worked in so far, which was mainly northern Spain, it's still heating. It's still very, very heating dominated. We haven't yet worked on the project where it's come to the point where it's so warm and humid in summer that we'd have to look at alternative strategies. So at the moment, all of the projects, they do all the dehumidifying through the ventilation. I think once the climate is warm and humid, you'd probably be looking at different dehumidification solutions. I'd be happy to take on the challenge if we get a project in a different climate.
Well, Florida's probably a couple years away from doing that, maybe.
But maybe in some climates you just have an outdoor pool in summer, right? And you just need to then open up the doors and say it's outdoor conditions are what we do in summer.
Yes, that's probably true.
Because of course you can open the doors and windows in passive house buildings.
Of course you can. Yeah.
Well, thanks so much for your time. I really appreciate it.
Thank you for having me and talking about leisure centers.
And that was Jessica Grove Smith, who is from Passive House Institute in Darmstadt. Really great to hear from Jessica again. Mary, what were the highlights for you?
Well, the overall approach, I mean, it's so helpful to have that research. When the first pool project got going and they got the research grant, it has such a follow-through effect for everybody, right? Because a pool guide was written, and now buildings with pools that are being designed and built now get to profit from that research that was done, and the thoroughness of the 2 years post-occupancy monitoring and what lessons could be learned from that. So I really appreciate just the support that everybody in the passive house community can get from these investigations into a particular building type.
Yeah, I remember hearing that and thinking, oh gosh, I wonder how many teams around the world right now are diving into a pool project or looking at designing this type of facility, having no idea that somebody has gone to this level of detail. These fantastic resources are there. You know, we don't have to reinvent the wheel with a lot of this stuff. Even if you do have to do a site-specific design, there'll be a lot of really useful pointers and previous research that could save a lot of time and money and produce a better outcome. Jay, what about you?
I thought one of my favorite parts was just how you could use just like building orientation in really smart ways where you have kind of a mixed center. So you have the pool is going to be on your south side because you need to constantly be heating it so you can get the solar gains from that. Have a little buffer area where it's slightly less warm for your shower area and locker rooms. And then, kind of on the north side have spaces that might need full cooling, like your gyms, or I think they have a couple of different like spin areas and like a dance studio, which I was hoping Jessica would tell us which one like people got the most sweaty in. I tried to, I don't know how I tried to phrase that, but she didn't take the bait on that. Because I feel like people would get have a little healthy competition of like, oh, I'm in the spin class. It's harder. We produce more heat than people in the weight room or something. But anyway, I just thought that was very just a common sense approach to design that can even not in passive house design, just using those principles can save energy and just it's a good idea.
Yeah, well, on that point, Jay, I think it was a really good question that that both of you sort of tried to get a bit more information about the variability, because obviously the internal loads has a lot to do with people, and particularly if they're very active and they're doing exercise, that's going to change the internal loads quite a lot. And it seems that just having good controls is the best way to manage that variability. Zach, what were your takeaways?
Well, I thought the building science of a pool was really interesting, and the knock-on effects that a better envelope can have on energy savings. So that the fact that the better envelope means lower condensation risk, which means higher humidity inside is okay, which means less evaporation from the pool itself, and therefore less water heating necessary because because typically the evaporation means a lot of cooling because of that cooling effect of evaporation. So stuff I had never really thought about, and was just such an interesting building type to think through, and
Yeah.
kind of surprising and cool, and it all made sense when she
Yeah.
explained it.
Yeah, I mean, I had heard that designing indoor swimming pools, buildings for indoor swimming pools are one of the hardest buildings to design, specifically around the issue of condensation. But yeah, I hadn't really thought about the fact that evaporation was one of the huge costs of running a swimming pool like that, but that makes sense. And if you can increase the humidity, then you drastically reduce that evaporation. And that seems counterintuitive to say, well, we just let the humidity go higher up. But if you've got
Right.
less of a thermal bridging and warmer surfaces, then that is the way to mitigate condensation rather than trying to dehumidify the air. And that's just using mechanical systems to try and keep everything in some sort of stable state rather than just relying on a really, really good building envelope, which is going to be much more cost effective and probably more durable over time as well, if you're not running the risk of having condensation forming. I thought the airtightness was really interesting. I'm glad you picked up that they went even more stringent than 0.65 and sorry 0.6 air changes, and interesting as well that they decided to go for a Q50 instead of an air change rate. And I was thinking as you were discussing that also makes sense for ensuring a high level of air tightness on a very large building, because as the size of the building increases, then the air change rate becomes easier to do, which therefore can be a less stringent metric, even if it's still at 0.6. You've probably got a really detailed explanation of that somewhere, Jay. But if you don't believe me, you'll just have to look it up. But it gets a little bit complicated. But that's interesting that that they went for a Q50, which is a measure of the permeability of the envelope as opposed to the number of air changes, and it is probably more of an accurate measure of building fabric air tightness. I don't know, Mary or Jay, did you want to pick up on anything about that?
Yeah, absolutely. I think it's exactly what you were saying, that, if you're looking at the overall volume, how many times it gets exchanged, well, in a larger building, there's, maybe certain areas are more airtight and other areas can be less airtight. But in a building where you really have to control the humidity and the condensation like that, then you can't have that sort of, well, this part of the building might be less airtight, but that's okay. You can't have that approach.
Yeah.
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 And I just loved how it's such a perfect example of why Passive House works, right? Because you're controlling the building envelope then allows you to look at the other energy uses inside, and it kind of has that cascading effect.
Yeah.
Yeah, that was cool.
I liked there was a small comment that Jessica made when you were asking about the pumps, Jane, and what were they really amazing special pumps? And she basically said no, they were just normal pumps.
Yeah.
But she then pointed out that it wasn't the pumps that were special. It was the design process and how detailed, and that got me thinking. She made a bit of a comment about doing a detailed design, but then really, really doing a detailed design, even to the level of thinking about, well, how much pressure loss will there be through valves, and it got me thinking about some building sites that I've been to where I'm pretty sure some installers are kind of making things up as they go along, because you got to put an extra bend in here and an extra bend in to get around a structural element, and every single one of those bends and joins and valves is going to have a an impact on that overall system. So we didn't go into it, but I can only imagine that this would be a really good case for doing really good BIM design and really planning out the paths of the pipes and the whole system to a very high level of detail, so that there's no surprises or additional bends and turns in those systems. I don't know if that was the case, but it just made me think that there's general design, but then there's really, really detailed design that isn't just about one system, but also figuring out how that system is going to work within the whole building, which you can only really do using a proper BIM model.
Well, it's just, I was assuming that there might, I mean, on top of proper design, that there might be this entire world of niche products for super high performance, uh, pumps for pool systems, maybe not high performance, but just efficient, or Energy Star or something that of course you wouldn't know about, because like that's such a small world of where 5,000 people in the entire world are really hyper focused on it. And I always like finding those little communities because they exist, and sure, Passive House is a great place to find them. So I was hoping that she'd get really, really deep into some nerdy stuff
Well,
that I wouldn't really understand.
But I think what we did get deep into was the design process, and that's where the magic happens, was that it's a truly integrated design process, which we often talk about, that you got to have everyone in the room early on. But I get the feeling that actually happened in this time, including having the maintenance people and the people who are going to be operating the building involved in the design process. So you're figuring this stuff out, and that's where the sort of really geeky and really detailed, interesting stuff happen, and not so much relying on fancy technology.
Yeah. And also just like the idea that, this is, I guess, more of a policy thing, but just Exeter as a city has really kind of led the way and been pretty amazing in the UK in terms of Passive House. Specifically, I remember Emma Osmondson, I think, was there for a long time. She's moved on, but I just think it's a huge expense. These are kind of energy hog buildings, so to build one to Passive House standards that's gonna reduce your energy use as a municipality is a good idea.
Yeah.
And yet it's still, I mean, Jessica commented on how valuable it is to have a client who's super committed to carrying through, because just trying to figure out how to streamline the whole building to make it meet Passive House is a huge project that you could easily see, if someone wasn't committed to it, at some point going, "Oh, this is so complicated." But so that's a shout out to the Exeter City Council for sticking with it.
Definitely. Awesome. Well, thank you, Joe and Mary, for getting in touch with Jessica, and thank you to Jessica and the PHI team for that awesome content and great ongoing research and resources they got available for that type of work. Zach, what do we got coming up on the accelerator?
Well, we're really excited to have Jessica Gross-Smith as an expert in residence at the Reimagine Buildings Collective, and she's going to be doing her first Ask Me Anything session with us this Friday, April 25th. So if you haven't joined the collective yet, you should join now so that you can take advantage of that. And again, the Reimagine Buildings Collective is where we bring together building professionals who are ready to tackle climate change, to share knowledge, to level up our skills, and build powerful relationships, so that we can create the healthiest, most sustainable buildings and deliver them cost effectively and thrive in the process. And these Ask Me Anything sessions are a really great way to get your burning questions answered and level up your skills. So that's really exciting. And then the other big thing I want to announce is that we will be doing Reimagine Buildings 25, our big online conference, global online conference, on June 12th at 9 a.m. Eastern, and it's called Reimagine Buildings 25, Past, Present, and Future. So we're going to be organizing this in 3 blocks. So past, we'll be looking at transformative projects that are revitalizing and repurposing our existing building stock. Present, we'll celebrate groundbreaking designs that are pushing the boundaries of what's possible in the built environment. And future, we'll dive into next-gen materials, cutting-edge technologies, and the future of resilient climate-positive buildings. So that conference, this online conference, will be open to all. And if you're a member of the collective, it'll also be free. But there's an admission for the conference. Otherwise, it's going to be really great. And Kim Davis, our programs manager, is pulling together a really fantastic slate of speakers for us. So good stuff.
Awesome. Good stuff. All right. Well, thank you everyone for another great interview, and we'll be back again next week on the Passive House Podcast.